Okay. Hello, everyone. Thank you for joining me today. So my name is Merwan Chinta. So before jumping into the presentation, so allow me a bit to share about myself and introduce myself to you all. So my journey with uh, technology started with solid foundations from .NET, and then I branched out into the machine learning world with a desire to make systems not just functional but also intelligent. So along this way, I have worn many hats, as a developer, crafting the code, as an architect, designing the robust and efficient systems, and also have been co-founder for a few startups, turning visions into the reality. And today, as we learn and delve more into the machine learning using the ML.NET, I will try to bring all these perspectives to show you how the machine learning can make our software tasks not just faster, but also smarter and more reliable too. I do also publish a lot of full stack technology related articles on my Medium blog. You can see I have the URL. It's @ Merwan01, my first name. Uh, it's like doing a bit of help to support the community where needed. So I'm doing my best on that. And then I have attached in my LinkedIn profile, so you can contact me for any questions if you have after this presentation, or if you are, I'm open to network. So if anybody wants to have some networking, I'm open to that as well. Alongside some of my professional interests, I have a passion for coin collecting. So I do have an album of coins collected from different countries around the world. So that's my personal interest. Uh, and all in all, so in the software development life cycle, I do strongly believe that design phase is fundamentally important in this life cycle. So that's the one which lays foundation for overall success, and try to minimize the rework or redesign where needed. Okay, uh, so let's get into here. So we are going to look at the potential of automation in our daily tasks, using this powerful tool called ML.NET. So we are going to look into recognizing a toilet seat from the images, like it is called like finding out the amenities in the bathroom detection. So I'll tell you later why I choose this topic. But if you are curious about the capabilities of machine learning, this is for you. So we can let's dive in with the spirit of discovery and innovation. Okay. So moving on to our agenda. So we begin by exploring why automation is not just a luxury, but it is a necessity in the today's world. I mean the digital world. So we will break down the complexities of the machine learning into simple concepts that you can grasp and pay attention and appreciate the machine learning concepts. So then we will steer towards the ML.NET and its capability in recognizing everyday objects, even something as dull as detecting a toilet seat, which turns out to be a window into the capabilities of intelligent systems. And then we'll walk through the steps of data preparation, model binding, the crucial phases of the training, evaluation, and prediction. So all this bundled together as a model that we are going to build in this presentation. And each of these building blocks each of these steps, are like a building blocks for this to create a system that can think and perceive the world like much as like humans do. Then we'll also have a technical demo followed by this explanation. And at the end of this, we'll also have a quick look about detecting the objects using Azure. Okay. The next one, jumping in. So I would like to first of all give a high-level overview of importance of automating a detection and how it fundamentally enhances our operations. So how does automation detection make a difference? Let's say, imagine you have thousands of property listings on a real estate website, and each property comes with numerous features that potential buyers or renters are keenly interested in. Like, the traditional process, it involves individuals manually reviewing and listing these features, like a process that's not only time intensive but also error prone because it was manually maintained. So now if you want to automate this process, the system can review hundreds of images, accurately identify and list all the amenities within seconds, and which is really a game changer in this case. So it ensures that the listings are quickly updated and the information provided on your property websites is accurate. So this gives you a speed, reliability, and you can translate directly the customer trust and have faster transactions, hopefully. And I have a similar example coming to the hospitality sector. Maintaining standards for rooms is non-negotiable. So, but how can we assure every room uh, in the hospital is checked for all amenities after the cleaning? So through automation, we can have a system in place that can scan the images post cleanup to confirm if everything is in place. Again, this is just an example that what we can do. So this kind of automation supports the staff, enhances efficiency, and importantly, guarantees the guest satisfaction. The another area where we can use this automation is the retail industry. Uh, Here, the retail department can greatly benefit from this automating detections. So let's say, for example, a warehouse. You have an automated system. It can scan the racks and identify the stock levels and even detect if an item is out of stock and alerts about restocking. So this capability can lead to improved inventory management, reduce the likelihood of the stock outs, and enhance your customer experience overall. So the gist of this automation detection lies in the ability to replicate and surpass the speed and accuracy of human capabilities in specific tasks. So by integrating this machine learning into our systems, we can process vast amounts of visual data, make informed decisions quickly, and also act upon them in real time. This also helps in cutting the costs and elevating the quality of service. We will make use of machine learning to identify features such as a toilet seat in bathroom images. It sounds simple, but I want to emphasize the process of how the machine learning models predict what we need to know for that. Okay, the next one, a little bit overview about machine learning. So machine learning is like teaching a computer to solve a puzzle, but instead of giving it a step-by-step instructions, we give it examples and let it find the pattern for us. So it's a part of an artificial intelligence AI that helps computers get smarter by learning from the data. You can see the top table. It contains features, labels, and class. So let me walk you through what it is with the example. So imagine we are teaching a computer to recognize fruits. So we show it with lots of pictures of apples and bananas. The thing it looks at it, each picture, like the color of it, the shape, the size, and these are called the features. The computer uses these features to make a good guess. When we tell the computer, hey, this is an apple or this is a banana, those are called labels. So the label is what we are trying to predict or the correct answer in this fruit puzzle. And let's say if we have a bunch of fruits to sort out or group them, uh, we want to tell the computer uh, to sort it out. Let's say it's like a group of apples or a group of bananas. So these are called the classes. So in machine learning, um, there are different ways we can teach a computer. So if you see my second table in the presentation, I have something called supervised, unsupervised, uh, semi-supervised, and reinforcement learning. So let's see what a supervised learning is, with some examples. So it is like, teaching a kid to ride a bike with training wheels attached to it. So we give the computer examples with the labels so it knows the right answer while it practices. So that's what is called a supervised learning. So it learns from the examples that we give. And unsupervised learning is like, giving a kid a box of Legos without the manual. The computer looks at the data without labels and tries to find patterns on its own. So that's what is unsupervised learning. And semi is like, mix of both supervised and unsupervised. We give computer a few labeled examples and it uses them to make sense a lot more data than that does not have labels. So when we come to the reinforcement learning, this is like, computer learns through trial and error. Assume like playing a video game. You want to reach your destination to find a treasure. uh, the character inside your video game, um, it makes its choice. Uh, if it goes a certain path, it might get more rewards. If it goes in a certain another path, it might get penalties. So based on this, the machine itself learns what is the best way to find its destination by getting rewarded or getting penalized. So that's what we call it as a reinforcement learning. So the machine learning, think of this as, the computer becomes more clever with each piece of information it receives or we provide. So understanding these basics is key to see the full picture of how we can apply the ML.NET machine learning for practical tasks, like recognizing whether there is a specific object inside a picture. So it's a start to design smarter and bigger solutions. Okay, now let's get started with the overall what is ML.NET. I mean, some of you might have already aware of this, but I just want to give a brief for those who doesn't. So it's a free open source cross-platform machine learning framework designed by Microsoft for .NET developers. So ML.NET allows us to integrate machine learning into our .NET applications without the need to be a data scientist. So think of it as like a bridge, a way to bring powerful data-driven functionalities to your .NET environment. Now the question arises, what problem does ML.NET solve? So in traditional .NET applications, incorporating machine learning features would require a lot of heavy lifting. Uh, you need to understand the complex data science algorithms, manage those dependencies, and possibly even learn a whole new programming language or a framework. So ML.NET simplifies all of this process by acting as a wrapper around our complex machine learning tasks. So it gives us the ability to use pre-built models or train the custom models that we built to recognize the patterns, make predictions, and learn from the data that we provide, all within your .NET ecosystem. So with this ML.NET, we can accomplish a variety of tasks that were once out of reach for many .NET developers, including myself. So with the arrival of this ML.NET, we can predict future trends, categorize the text, analyze sentiments, and of course, recognize objects within the images. And that's where our example of toilet seat detection comes into play. So by training a model with the ML.NET, we can efficiently process images of various bathroom settings and accurately identify whether a toilet seat is present. In the presentation slide, I have used ML.NET to analyze two images, one featuring a toilet seat and the other a bathroom sink. So ML.NET successfully identifies using the machine learning algorithms models to uh, successfully identifies a toilet seat and marks it in a green color, and a bathroom sink, you can see it is marked in the red color, showcasing its precision in distinguishing between different bathroom fixtures. So with the help of this, harnessing the power of ML.NET, we can all do this without stepping outside the comfort and familiarity that the .NET platform provides to us. So if at all you have any all questions during this presentation, I have a Q&A session low. So let's keep your questions and we can discuss at the end. Okay, so to build a custom machine learning model with ML.NET, we need a well-organized data set that can be used, that should be used for training, testing, and a defined data model for input and output, and a carefully constructed pipeline that includes data transformations, a learning algorithm, which is tailored to our task. So in this exploration of the toilet seat detection, our journey starts with two fundamental steps. One is organizing our data, and the second is crafting our model. And these two fundamental steps will bring our project to life. So let us walk through these steps, organizing our data. So here you can see I have sorted our images into two distinct categories. One is uh, a folder of a set of images that contains a toilet seat. And on the right side, I have another data set which do not contain a toilet seat. But pay careful attention, both are like bathroom amenities. One is with toilet seat, the other one is without toilet seat. So this simple act of categorization is crucial. It's how we teach our model to understand the difference between the two. So each image is in this data set is tagged accordingly, serving as a direct signal to ML.NET about what it is trying to analyze. So the process isn't just about sorting the images. It's also laying the groundwork for intelligent recognition, I would say. And then comes the training and testing piece. So after our images are sorted and labeled, we split this data set into two sets again. So one for training our model and the another for testing its accuracy. So this is the training set where our model practices and learns. The key here is the model should identify our targeted object, which is a toilet seat, in the new image and any unseen images. So to get this prediction level, we need to train uh, uh, with the various kinds of data sets. And to build the model with our data being prepared, we need to construct something called a pipeline. So a pipeline is a series of steps that guide how the model processes and learns from the data that we provide. So this includes transforming the image data into a format the model can work with, and selecting the right algorithm for the learning is important as well. So the beauty of ML.NET is its simplicity and power. So it allows us to focus on what we want to achieve rather than getting caught up in underlying complexities of machine learning algorithms. Say which model is perfect, is this, try with this one, or try with YOLO or some other algorithms. So, so ML.NET kind of wraps all that complexities for us. And we train our model with the prepared data, teaching it to distinguish between images and without the toilet seats based on the patterns it observed. And as we reach the critical phase of our ML.NET, this is like, the stages of training, evaluation, and prediction. This is where our model truly comes to life. So in the training the model, in this stage, we feed our carefully labeled images into the ML.NET's learning algorithm, and our algorithm model goes over the images of bathrooms with and without toilet seats, learning to spot the difference. And this is where the model has its ability, drawing on wealth of examples that we provide, to recognize what a toilet seat looks like in various settings, various bathrooms, various images. But practice and training alone isn't enough in this process. I mean, that's everywhere, right? So we need to test our model, how it is performing. So this is what we call an evaluation phase, where we present the model with new and unseen images, and it is a rigorous test of our model ability to generalize what it has learned to the new data. So here we measure the success not just through raw accuracy, but by how well the model can make the right call in scenarios it hasn't encountered before. Does it correctly identify the presence of a toilet seat, or does it falter? And then the next is predictions. This is the final stage. And with our model being trained, evaluated, this is where this is the time to put our model to work on the real world data. So we task it with new images and we observe. So the key here is observation. So does it accurately identify the toilet seats in a variety of bathroom images? This is where we see our efforts as the model applies its learned intelligence to make decisions just like we would, but at a high scale and consistent accuracy. And this is all a iterative process, the refining the model based on the evaluation results for improved accuracy. It needs to the model needs to keep trained, evaluated, and prediction on a regular iterative process to keep our model up to date with the trends that are being evolved outside. So what we are achieving with this ML.NET is not just about detecting a toilet seat, it is a step towards making our software interact with the world in a way that mimics the human perception. So it's a transformative process that turns static data into dynamic decision-making tool. Okay. And we are about to see what we have talked in action in a couple moments. So here you can see on the left side, you will witness that our model successfully identified a bathroom with a toilet seat. And on the right side, there is a bathroom too without a toilet seat. And um, uh, and the model says this isn't a toilet seat. So this is where our training pays off and where we see the true potential of machine learning for everyday tasks and practical tasks. So let's move on to the technical demonstration where you are going to see how this ML.NET distinguishes between the two with precision. So, let me share my Visual Studio. Right. So I did this is a .NET 8 console application. I have named it toilet seat detection. And then if you see my uh, project file, I have installed the necessary YAML.NET NuGet packages. The first one, the basically is the Microsoft.ml, that is the ML.NET NuGet package. And then I have also installed a related couple other packages, which are image analytics and vision. These are required for image related machine learning tasks that we are going to perform. And behind the scenes, ML.NET image classification, like observing the image and detecting the objects. That's what we call as image classification. So the ML.NET image classification relies on the TensorFlow under the hood, and it is essential to have that NuGet as well. So it uses the TensorFlow for its deep learning capabilities and interoperability um, for extensive ecosystem and some pre-trained models. So we need to install the SciSharp TensorFlow to get our project going. And then um preparing and creating our data model. So I have created a new class called bathroom data. This defines a data model that represents our input data. So image path, the property that we have right now here, this holds the file path of the image, and this is used to load the image into the model for training or prediction. And we have a label. So if you remember in our previous slides, the overview of the machine learning, we have something called features and labels. So features are the inputs to a machine learning model, and the labels are the things that the machine will try to predict. So here, the label property, it represents the classification of the image. So in this case, it would indicate whether the image is a bathroom with a toilet seat or without a toilet seat. So this property is crucial during the training phase. ML.NET uses this label to understand what each image represents and learns to associate the visual features of the image with the corresponding category. I have also created another class called a bathroom prediction. So this is nothing but a predicted label, a simple and descriptive string where the machine will give us the output. It will contain either with toilet or without toilet. And then let's all tie it together in our programs. Yes. I have some configurations related from the JSON files, like the path to images, folders, and stuff like that, which I have wrapped in my app settings JSON file. And I have collected all of them in the variables, what I need, and some basic validations before running up. So the main um, thing, ML context, you can see here in line number 9. So this is where this is the starting point for all the ML.NET operations. We need to load the images into a list that ML.NET model can understand. So you can see here, I have a directory. Let me pull that up quickly. Okay. So I have two directories here, images with toilet and images without toilet. So so you can see these are some of my images. This is the data set that we will give the model to train. And these are the images without a toilet seat. And so I have set up the two folders here. And what I'm doing here is I'm collecting all the list of images from that specific folder and creating the DTO that we have created, the input DTO, which is bathroom data, and giving the full path, and I am labeling it with toilet. Similarly, I'm also labeling the other folder without toilet. So once we have uh, this data set, we need to split this data set into a training and testing, two different parts. So ML.NET provides methods for this. I mean, you don't have to do anything special in this case. So you can see here, I have my training set and I have my test data set. So what you have to do is once you load all the images into the ML context, you call this as something called a data view. From this data view, you have a test fraction, which I have specified a 0.5. This represents 50% of our entire data set will be set aside for testing the model performance, and the remaining 50% of the data will be used for training the model. So, from the two folders that I have shown you together, the 50%, combined 50% will be used for training, and the remaining 50% I'll be using it for testing. And once you have your training data, test data, the next one is pipeline. You will need to define the pipeline. So the pipeline, the sequence order is crucial. So it is a sequence of steps, as we have learned earlier. It defines a series of data transformations and learning algorithms, steps that are applied in order they are appended. So each step prepares the data for the next one, and the order determines how the input data is transformed and used for the training mode. So if you see here, the first one, ML context, transform, conversion, map value to key. And so what this specifies is this line transforms our string label, which is the input. What we have is with toilet and without toilet. So this converts the string label into a numerical value that we call it as a key, label as a key. So the ML.NET algorithms or any machine learning algorithms, they better work with numerical values than strings. So that is the reason we are uh, converting the value to a keys by defining what is the input and what should be the output column name in this pipeline. So it's like mapping the label from our data set to a key in a new column that we call label as a key. And then the next one in the pipeline is load raw image bytes. And here you can see we are appending another step uh, in this pipeline where the actual images of the data being loaded. It reads the images from the specified folder and loads them, converts them into a raw byte array, and makes a new column called image, which our model will see as an input feature. And the next one is image classification. So this line, this is called a trainer. So in the pipeline, we have converted labels, the things that we predict, to numbers, numerical values. And then we have given the features, which is our images as an input. And then we are selecting a trainer in this case. So even though our task is binary classification, determining whether this is a toilet seat, yes or no. So here I'm using a multi-classification trainer because for its robustness, there is nothing wrong. You can I mean in using this multi-class classification. So I mean there is a lot more detail into different types of classifications available in ML.NET, but let's put that out of scope for this presentation. For your sake, I'm selecting one of the trainer, which is called multi-class classification. And this trainer, what it will do is it will learn from the image column. So this is the image output of the second in our pipeline is the input for third in the pipeline. So this image column, which is our features, and the label as a key column, which is our label, so it will help to distinguish between the images with toilet seats and those with not. So the trainer will train from the two. And the final is again the transform conversion map key to value. So here you see map value to key, and this one is key to value. So what this is this is a final step in our pipeline that transforms the predicted label keys back into the understandable string labels that we want. So when the model predicts a label, it is in the form of a numerical key. And this transforms back to it's a string like with toilet or without toilet so that we can interpret the model predictions. And that's how we define our pipeline. And the next one is fit, which we called train the model. So to train the model with the training data we have prepared earlier, so we use a method called fit on the pipeline. So we have the pipeline defined here. On the pipeline, you have a method called fit, and you give a training data that you have split earlier. So this fit takes the training data, applies the sequence of transformations and the learning algorithms defined in the pipeline to the data that you provide. So essentially, what it does is it fits the model to your data, learning from the features and the corresponding labels. During this training phase, the model learns the patterns in the data that correlate image data to labels, whether the image contains a toilet seat or not in this. And the output of the fit model is a trained model. So now your model, you have customized the model by defining it with a pipeline. You have trained the model. Now your model is ready. And you can test your model to make some predictions. So you have an option to save the model and reload the model. So let's say I'm running this application. I mean, I don't want to go all this process again and again. So what I want to do is instead, I want to save this model so I can push this to higher environments like QA, UAT, stage, prod, etc. once your model is trained. Or you can also share this training model with your other developers, other administrative staff that you're working along in your with your colleagues. So that's where you have a method to save the trained model, and you can specify the location where you want to save. And you can also load the saved model using ML context. So you don't have to keep on training, feeding, defining the pipeline again and again. You can just load the model and start prediction using it. The next is with our trained model, we do the predictions. So here we give our test data. So if you remember, we have split our entire data 50-50%, one with the training set and the other one is the test set. So with the test set, we evaluate the model. So this is what once our it's important, to evaluate the model performance with this test data. So this will measure the accuracy of the model that we have built, customized. So And this also assess the performance of the model that we have trained using uh, a separate test data set that was not used for training. So it computes various metrics, like accuracy, precision, recall, some scores, depending upon the type of machine learning task. These metrics give you insight into how well the model is performing. So you can get all this metrics from after you evaluate the model, it will give you a bunch of metrics. So by observing those metrics, you can uh, retry or retrain the model with the more data set and stuff like that. These results, the metric results will help to understand the quality of the model that you have built. For example, high accuracy indicate good model performance, while low accuracy might signal you need more training data or a different data processing or a different model or a different trainer. uh, that's what it is. And I mean, just for our understanding, I am logging micro accuracy and macro accuracy with a format called F2, like digitizing it to 2 digits. So macro accuracy meaning the average accuracy of the model on all the different things it can predict. Like treating each thing equally, no matter how often it appears in the data. And micro is like, measures the overall accuracy of the model, predictions it makes, training into the account, the frequency of each thing it predicts. And I think there are like a formulas on how these gets calculated on macro and micro. So I mean, if you have any questions, you can reach out to me later after this presentation. I would be happy to provide how these things were calculated. And then comes the prediction phase. So from the model, we are creating a prediction engine, and we are passing in the trained model. So this is where our model will make predictions on the new data that we provide. So once I have the prediction engine, I'm passing in a valid image to predict, and I'm also passing an invalid image to predict. So valid image meaning a bathroom with a toilet seat, and invalid is the other way, without a toilet seat. So my assumption is the valid image predicted label should be with toilet, and the invalid image prediction should be without toilet. Okay, that's a lot to take in. So let us run this application and see how it goes. The first time you run this application, the fit model I explained you might take a bit of time, since I have already trained this on my machine. It should be pretty fast. Okay, so you can see the last couple of lines. The trained model predicted for image with toilet is with toilet, and the invalid image is without toilet. So our model, what we assume, it has correctly identified our cases. So if we see here, so this is the image. This is the image I'm using for prediction. So to this model. And this is the another image, which is an invalid image I'm using for prediction as well. So this one, the model predicts there is no toilet seat in this, and this one, the model predicts there is a toilet seat in it. And these images are not in your training set. So this is a completely new image altogether. And you can see I have created the model as a zip file. So this is the zip that is stored, and that model contains some schema and relevant information that the ML.NET understands to preload the model without going into the training data preparation phase, you can directly go to the prediction phase. And now we have seen the emphasis, I have emphasized the process, how the machine learning works, what are the inputs, features, labels, what are classes, what are the different types of machine learning models we have, and how do you build a pipeline, how do you train your model, create a model, customize a model, evaluate and predict. So, now you have got an overall picture of this machine learning. Now, the other one is, let me show you the other one. Okay. Okay. So you can do all this even without ML.NET to make our things easy. So let us quickly explore the simplicity of object detection with Azure Cognitive Services, ACS. So with just a few clicks, Azure enables us to identify the objects within an image, making a machine learning accessible for all, regardless of the machine learning expertise that we have. So let us quickly take a look at how this powerful service can transform the way we interact with the visual data. I'm sharing another application. This is also I think it's in .NET 8 I created. So I have named this as a image classifier. Um, so the idea here is I am using Azure Cognitive Services NuGet packages, and there is something called Computer Vision Client in this NuGet pack, which comes from that NuGet. So all you need to go is you need to go to your Azure portal, uh, create a subscription for Azure Computer Cognitive Services, and you can get your subscription key and an endpoint. That's all you need. You don't need anything else. So once you instantiate your client, I am sending the same path that I am used earlier to predict. So what it will does is it will predict and tell us what the output is. So let me run this application. Okay, wait. Okay, so the model ran, and you can see here I have given this image, and the Azure boxed it with its coordinates, and it also labeled it as a toilet. So as simple as that, we don't have any knowledge of the machine learning in this case. All I asked is, upload an image and detect what's inside. And Azure detected it for us using the machine learning algorithms that it has, and that provides as a service for us. So if you see the same in my uh, another slide, so here I have uploaded a picture of dogs, and the ACS service, it identified some as dogs in a general basis, and some as cats, and it even indeed went ahead much deeper, and it says, hey, English Springer Spaniel. So this is another dog that's bred. So it correctly identified what's in there as well. So the reason I went through this process is you guys will understand how this machine learning works. And uh, before even diving into the Azure, it's kind of gives us a sense what it does behind the scenes. And that's where we went through this process today. So I hope, this session is insightful to you all. So now, if you, I hope you have followed through this journey into the machine learning with ML.NET and how we made it pretty fast with Azure. Now I would like to hear from you if you have any questions or share insights that you guys have. Okay. Um, one frequent question that might come is like, how do we ensure our model being trained or detected to toilet seat remains accurate and relevant over the time, especially as the bathroom designs and the light conditions change. So the key to maintain an accurate model is continuous learning. With ML.NET, we can update our models periodically with the new data that reflects correct trends in the bathroom designs and lighting. By retaining the model with the fresh data, we ensure that it stays tuned to our nuances of the images that it needs to analyze. Okay, and uh, the another thing is, I think I got a question, how to recognize math matrix using ML.NET. Can you uh, elaborate what is like a math matrix meaning? Okay, so you would typically use techniques like image classification. You would need a labeled data set of images containing matrices, pre-process the images, then train a model. Convolutional network, neural network is the one to classify them. I hope that answers you. And also a vector with a specified number of rows and columns in the context of uh, linear algebra that represents a matrix where one of the dimensions is fixed to 1, indicating that it's either a row vector or a column vector. Okay. And another interesting aspect, I don't know, that might uh, one might wonder about its scalability, right? How can we scale our ML.NET to handle larger dataset or more complex detection tasks beyond the toilet seats? So ML.NET is designed with scalability in mind, so it can handle larger datasets by allowing us to train models incrementally or in the cloud, leveraging additional computational resources. So, and even for complex tasks. So we can build upon existing model, employing more advanced features of ML.NET, or even customizing our algorithms to suit specific needs. So this flexibility is what makes our ML.NET a robust tool for our machine learning projects. And I hope this session is insightful. So thank you all for your time and engagement today. Your participation and curiosity makes the exploration of machine learning with this ML.NET not just informative, but it's exciting, truly exciting. Uh, and thank you all for your time today. I look forward to seeing how you will leverage these insights in your own innovative projects. Thank you all. Have a good day.